Hey guys, in front of you, you see two relational objects, let's call them. One is an equation, one is an inequality. And here's what I want you to do. I want you for both of them to take what you got there and flip them. So rewrite each one of those and then just pick up the left and the right side and flip them, write them down, and then what I want to know is, does that make any difference? Once I do that, have I changed anything? Why or why not? So today's objective is to solve and graph two-step inequalities and to solve and graph multi-step inequalities. We can generalize this to say that I want you to solve and graph pretty much any inequality, just like you can solve any equation at this point. So let's talk about these two. And pull up my pen here, excuse me. I've got x equals 5, and if I just take these things and I swap around the two sides, where the x was is now a 5, and where the 5 was is now an x, and I ask, have I changed the meaning there? Well, not at all. I can flip sides on an equation all day long, and nothing changes, which makes sense from the definition of an equal sign. Both things on either side are exactly the same, and so swapping them makes no difference whatsoever. However, if I look over here and I swap these, and now the 5 is where the x was, and the x is where the 5 was, over here this has made a big difference. This states that x is less than 5, and this one states that 5 is less than x. And if you stop and think about it for any length of time, those can't both be true. And so what happens is, if I flip the sides of an inequality, if I move the x to the other side and the 5 to the other side and just leave the inequality symbol the same, then I have changed the statement. And this is no good. We do not want to do that. And so that's one of the things we're going to learn about inequalities as we go to solve them. Really, everything that we're going to learn about solving inequalities, all the stuff from solving equations, is still true. All of the techniques that you would use to solve an equation, you use those exact same techniques to solve an inequality. Literally zero difference, except there are two new things we've got to remember, and at the end, I have to graph my answers with an inequality, just like we practiced in the last assignment. So let's talk about the first thing that we cannot do. First, in an inequality, the order in which things are written matters. We just saw that for an equation, I can swap the sides and it doesn't make any difference. With an inequality, if I swap the sides, it does make a difference. And so I cannot just willy-nilly flip the sides of things without flipping the direction of the inequality. And here's what I mean. We gave the example earlier of x is less than 5. If I flip the sides around on that, and I want to maintain the truth of that statement, if I swap the sides, I have to flip the direction of the inequality. Notice the duck's mouth is open to the right. To keep this true, I have to flip the inequality if I flip the sides of the inequality expression. So here we go. This reads x is less than 5. This reads 5 is greater than x. And if you stop and think about it, it's complicated. You can do it. Both of those things are true if I flip that inequality. If I just left this as a less than symbol, it would not be true. Now, that's really not going to come up that much unless it looks like this. This is the big one to remember with inequalities. If I multiply or divide both sides of an inequality by a negative number, I must flip the direction of the inequality. And the reason for this is that if I multiply or divide by a negative number, it's functionally the same as if I switch the sides, just like we talked about a second ago. And so I have to reverse the direction. So for instance, if I had negative 5x is less than or equal to, say, 25, and I divide both sides by negative 5, it doesn't matter if this top number is positive or negative. But if this bottom number, the one I'm dividing by, is negative, when I rewrite this, I have to switch the direction of the inequality. So whereas it did face this way, now it has to face this way. And the reason being is that if we were to look at this in great detail, which we're not going into unless you just really want to pull me aside and ask about it, is that when we divide by that negative, it's almost the same as if we just brought this over to the other side and then brought this over to the other side. And when we do that, we know we have to flip that. So now what we're going to do is we're going to look at 6 examples of this, ranging from easy to not so easy, so that you can see what this should look like. So in our first example, this is an example of a fairly easy one. I've got 1 is less than r plus 12, and I want to solve and graph. So to solve means to get r by itself. So I need to isolate r. That means I need to get rid of this plus 12, and I get rid of a plus 12 by subtracting 12. 1 minus 12 is negative 11. My inequality sign stays the same. I didn't multiply or divide by a negative number, and I'm left with r. So now my inequality states that negative 11 is less than r. So my area of interest for my graph is negative 11, so I'm going to put a circle around negative 11, and I want to know my variable, my shaded region, is that greater than, less than, or equal to negative 11. And if we read this, we see that negative 11 is less than r. Duck's mouth eats the bigger one. That means r is bigger than negative 11. And so I'm going to shade the part of the graph that is greater than negative 11. And there it is right there. So now I have solved and graphed this inequality. Next up, I have another fairly simple one. This is just a one-stepper, but one of our unique situations for inequalities comes up. Here I've got 50 is less than or equal to negative 5n. I want to isolate the n, get it by itself, but we're multiplying by negative 5. So to undo multiplying by negative 5, I divide by negative 5. 50 divided by negative 5 is, of course, negative 10. These will cancel, and I'm left with an n, but I divided by a negative number, so I have to flip the direction of the inequality. So that means my point of interest is at negative 10. I now have 3 regions. I have greater than, less than, or equal to negative 10, and I see which I need to shade. I see the duck's mouth is eating the negative 10, so that means n is smaller than, n being my shaded region, it's smaller than 10, but it's also got this line, so it also could be equal to, so I fill in my circle and leave this as a closed circle. Now I can get to some more complicated examples, but if you remember what we were looking at from equations, this is nothing new. When we see the distributive property, we know we need to do that first. So we distribute the negative 6 times 3 would be negative 18. Negative 6 times positive n would be minus 6n. Now we need to isolate the n, so we're going to get rid of any addition or subtraction that we have going on, which means in this case adding 18. So I would get 108 is greater than negative 6n. I still want to isolate the n, so I have to undo multiplying by negative 6, which I do by dividing over here. This is going to cancel out. And now I'm left with this situation, oops, got a little ahead of myself there, where I have divided by a negative 6. So I have to flip that inequality, and now we just have to get this, which would be negative 18. So again, everything I know to be true works out on this, and the only difference is in this step, when I divide by a negative, I have to flip the sign of that, the direction of that inequality, And so I end up with negative 18 being less than n. I go ahead and circle that, and I know that in my shaded region has to be bigger than negative 18. The duck's mouth is eating the n, so I want to shade in all the places greater than 18. And there we go. For this example, I have another two-step equation. Negative 5 is greater than or equal to negative 1 plus x divided by 4. Remember, when I don't want to see fractions, I want to think of them as division problems. So now what I need to do is undo any addition or subtraction going on with the variable. So I'm going to add 1 to both sides. And I find that negative 4 is greater than or equal to x over 4. I need to undo now dividing by 4. Remember, I'm trying to isolate my x, and here I'm dividing the x by 4. So to get rid of that, I'm going to multiply by 4. Instead, 4 times negative 4 is negative 16. These will cancel. And now the question becomes, do I flip the inequality? The number over here that I multiplied my number with was negative, but look at the number that I multiplied by. I multiplied both sides by 4. 4 is not negative, so I do not flip the inequality, and it stays just like that. Negative 16 is going to be greater than or equal to x, so notice that the x is smaller than negative 16, so I'm going to shade everything beneath that. And it could be equal as well, so I'm going to close in that circle and shade it as well. And there's my solution. In example 5, we start to see now that in an inequality, just like an equation, we can have variables on both sides. There's nothing says we can't. And so I write this. First thing I want to do is look for any distributive property. There is none. Look for like terms that I can combine. Hey, we got 2 of them there on the left. Positive 2 minus 8 would be minus 6. Now there is no more simplifying. There's no distributive property or combining like terms I can do. So what I am going to do is gather my variables to one side. I'm going to go ahead and get rid of this r on this side by subtracting r from both. And I get negative 6 is less than or equal to 2r minus 1r is just 1r plus 2. Now to solve that, I'm going to subtract 2 from both sides, and I find that r must be greater than or equal to negative 8. As written, negative 8 is less than or equal to r. So I get a circle around negative 8. r is bigger than negative 8, so I want to shade in everything bigger than negative 8. But it could also be equal, and so I want to close in my circle as well. And then finally, let's look at one where we have to do a lot of simplifying, and I have variables on both sides. Kind of a worst case scenario, but we still know what to do. First thing we're going to do is undo this distributive property that we see here. So I get 32a plus 12 plus 5 is greater than 17 minus a. I can now combine like terms on this side. So I get 32a plus 17. And then I have over here 17 minus a. Now I want to gather my variables. I'm going to get rid of this minus a by adding a to both sides. And so I find that 33a plus 17 must be greater than 17. Now to isolate my variable, I subtract 17 from both sides. I'm going to bring this up here so I have a little more room. And when I subtract 17 from both sides, I get 33a is greater than, whoa, look over here. 17 minus 17 is 0. On this side of the inequality, I just end up with 0. If everything eliminates, because remember these cancel over here on this side, if everything eliminates, we can put 0 in as a placeholder. Now, still need to isolate that a, so I'm going to divide by 33, but we don't even need a calculator for this one. we know that when I divide 0 by anything, my answer is still 0. And so we find that A is greater than 0. So I would shade in everything bigger than 0. And it's not equal to, so I leave my circle open. And there we go. So remember, with inequalities, it's just the same as solving equations, except I cannot flip the sides as I see fit. And if I multiply or divide by a negative number, I must flip the direction of the inequality. And also, don't forget to graph at the end.